Hi there, welcome to this video on transformations of functions. This is a very important lesson that will transcend not only this unit, specifically talking about polynomials, but also impact future units when we talk about exponentials, logarithms, trigonometric functions. Very important topic, transformations of functions. So we are going to learn and talk about transformations, and then we will also go ahead and determine domain and range of transformed functions. I want to go ahead and define a function as g of x. G of x is equal to a times f of b times x minus h plus k. Now here are parameters that should seem familiar to you. A, h, and k. Those are very common. And then the b is similar to an a, but this is a horizontal transformation output. And it acts exactly the same as a. It will give horizontal dilations, stretches, making it bigger, compressions, pushing it more compact towards the y-axis, and then even causing a reflection, flipping around. The thing to remember is that we have horizontal transformations. These affect the inputs or your domain, your b and h, and any horizontal effect can be calculated as bx plus h, bx plus h. And then your vertical transformations are things that affect the outputs. And so these are your a values and your vertical translation up, which is your k values. And the way to calculate those is ay plus k. Now, the thing to remember also about your horizontal transformations is that these are not always as they seem. Your b parameter, you're often going to have to take the reciprocal. So whatever you see in your function, you're going to have to take the reciprocal. That's your horizontal dilation factor. Your h value, remember, is always the opposite. You should see a minus h, okay? A and k, those are straight up. They are what they are, okay? And so here is a list of kind of the effects of each of them, right? Your a value will control vertical dilations and then reflections across the x-axis, while your b value is horizontal dilations and will reflect across the y-axis. Your h value will take you left and right, and your k value will take you up and down. And I have a Desmos graph here. Maybe I'll put this link to this so you can play with it on my website, if you want to change these parameters. But I have a function f of x, which you can see here is x times x plus 2 times x minus 3. You can see there are zeros, and I defined a new function, so I turned off f, right? F is there if I turned off b, so f is there, but I defined g as the parameters, and so I just want you to kind of see, right? Here's my a value. If my a value is positive, I get a horizontal dilation, and then if it's negative now I get that reflection, right? I get the reflection of what I had, okay? And then we can go ahead and kind of see the b value here. So you see how it got, well, I guess technically the b is smaller, so it's going to be reflection, right? Or maybe let me do this. I'm going to change this. We'll go 1 over b. Let's reset this to 1. And so you can see here your actual b factor. So if my b is bigger than 1, we get that stretch, right? It's horizontally stretching it out. And then watch, now it gets between 0 and 1. It's getting compressor tighter and tighter towards the y-axis. And then when it's negative, it's going to reflect. Whoop, reflected the other direction. Okay, so there's your b parameter. Let me reset this to 1. And then here is your h parameter, right? It's just going to take your graph to the right, to the right, to the left, to the left. Okay, and then let's go ahead and check out k. K, we'll move your graph up or down. Okay, so those are the parameters. Now, let's go ahead and just kind of talk about some of the transformations here. 2 examples, 2 practice ones. Make this full screen. Okay. The function f and g are defined for all real numbers. Describe the sequence of transformations that maps the graph of f to the graph of g in the same xy coordinate plane. What you want to do first is just identify your parameters. I see an a factor of 2, I see an h factor of 3, and I see a k factor of 1. So what are the effects that we're going to have? Well, we're going to have a vertical dilation by a factor of 2, and we're going to have a horizontal translation 3 units right, and we're going to have a vertical translation 1 unit up. AP Precalculus does not use stretch or compression, so you don't have to worry about the size of the vertical dilation factor. They just use dilation for everything. Okay, so very important. It's not a reflection because it's not negative. Let's check out example number 2. Example number 2, again, I have an A value here. That's 3. Now we have a B value, which is the reciprocal. So I always take the reciprocal of it. So 1/2. We have an H value. Looks like our H value is negative. Again, the horizontal components always change. They always try to get you. Okay, so there's your ABHK, and then what are the effects? Well, it looks like we have a vertical dilation by a factor of 3. Factor of 3. We have a horizontal dilation. Dilation by a factor of 1/2. And we have some translations here. We have a horizontal translation, 1 unit left. 1 unit left. And we have a vertical translation 4 units down. 4 units down. Okay, there you go. Hopefully not too tricky. Hopefully you've done this before. I want you to go ahead. I want you to pause the video, and I want you to try these two. I guess you can unpause me. I'll show you the solution to this one, but pause, check and see if you got this one. Okay, A is 1/3. That's vertical dilation by a factor of 1/3. H, -4, so we're going left 4 units. Did you get it? Hopefully you did. Okay, go ahead. I want you to pause video, and I want you to try this example here. Okay, hopefully you tried this one. B is 4. Did you remember to take the reciprocal? Hopefully you see x over 4, that's 1/4. 1/4. So you take the reciprocal of it, 4. Horizontal dilation, K is -8, so you're going down 8 units. Pretty straightforward. Okay, let's go ahead. Again, I want to remind you about the effects of these parameters. Horizontal transformations affect our input values by a calculation of B times X plus H. The outputs are affected by A times Y plus K. So if you want to see how something is changing, those are the calculations that you make. You multiply times the dilation factor, and then you add the translation factor. So let's look at this example here. They say here in the xy plane, the function b is graphed on the interval 0 to 10, and the point 4, -3 is on this graph, y equals b of x. So here's a point, 4, 3. So x, y. Which of the following points is on the graph of y equals 2 times b of x plus 4 minus 2? Well, what they're telling us is they're saying a is equal to 2. They're saying h is -4. And they're saying k is -2. So how's that going to affect my point? Well, remember, I have a horizontal component here with the h. So my x value is going to be 4 minus 4, 4 minus 4, which looks like it's going to be 0, okay? And then your y component, y, is going to be affected by the output parameters, the a and the k. So a times y, remember ay plus k. So 2 times -3 plus k, which is -2. So we get -6 take away 2 is -8. Answer A. Okay, example number 2, same type of question. In the xy plane, the function p is graphed on the interval -10 to 10. The point -4, 2 is on the graph of y equals p of x. Which of the following points is on the graph y equals p times 2 of x minus 3 plus 6? Again, what they're saying here is they're saying, hey, you have a b parameter, which is 1/2. You have an h parameter, which is 3. And you have a k parameter, which is 6. So my x value is going to be 1/2 times my x value, which is -4, plus h, which this time is +3. So I get -2 plus 3. I get 1 as my x value. So this makes it really easy. Our answer should be C. I'm just going to verify, our y value is 2 plus 6. You guys are like, I know. I was telling you. You're acting slow. Okay, so C. There you go. Bx plus h, ay plus k. Bx plus h, ay plus k. Go ahead, pause me. I want you to try this practice one here, and then I'll go ahead and show you the solution. Okay, hopefully for this one you got A. X is -4, y is -19. That's because your parameters are -3. H is 2, k is -4. So remember, bx plus h. Here we don't have a b parameter. Well, you do. It's just 1. So it doesn't affect multiplying y's. And we add 2 to give us -4. And then ay plus k gives us the -19. Go ahead, pause. I want you to try this next one here. Okay, for this one, hopefully you got B, 12,1. There's your parameters. There's the effects on x and y value. And that's it. Okay. We're going to go ahead and kind of do the same thing here. The table gives values for a polynomial function of f at selected values of x. Let g be equal to a times f of bx plus c, where a, b, and c are positive constants. In the xy plane, the graph of g is constructed by applying 3 transformations. Here they're going to give us some information. In this order, a horizontal dilation by a factor of 3. So when they tell us that, what they're saying here is they're saying b is equal to 3. Okay, a vertical dilation by a factor of 5. Okay, what they're saying is k is equal to, vertical dilation. They're saying a is 5. A is 5. Vertical dilation. And a vertical translation by 4 units. So k is equal to 4. What is the value of g of 3? So it's very important, first of all, that you understand here is g of x. Okay, and so I'm going to write g of x first. That should be step 1. What is g of x? G of x is equal to 5 if I can learn to write, 5 times f of b. So this is going to be, since it's a factor of 3, right here is going to be 1/3. 1/3. Remember, we got to switch it. That's the tricky part. Okay, and then plus 4. So what they want, here's what they want. They want g of 3. What's g of 3? And so all we do is we plug it in. F times 1/3 times 3 plus 4. Okay, so in this part we're going to get 1. 5 times f of 1 plus 4, which gives us 5 times f of 1 gives you -6. Plus 4, so it looks like, what, negative, oh my gosh, why is my brain freezing? -26? I don't know why I was so unsure of 5 times -6. I had trust issues for a second. Okay, there we go, -26. All right, here's a practice problem. Please go ahead, pause the video, and find the value. What's g of -4? G of -4. Okay, first of all, I should say you're using the same table as above. Hopefully that was clear. And step 1, identify your parameters. Here they are. Step 2, make your function. So g of x equals 3 times f of 1/2 x plus 6. Step 3, evaluate. So I plug in -4. You do have to find the value f of -2 from the table, which gives you 4, right? -2 gives us 4. Okay, and then you get 18 as your output. All right. Okay, Last topic here. Kind of the same idea. They say a table gives values for the function h at selected values of x. Which of the following is the table of values for the function d, which is h of x plus 2 minus 3? So again, what they're doing here is they're saying, hey, you have an h value that is negative 2 and a k value that is negative 3. So essentially, we're going left 2 and we're going down 3. So a couple of ways you could do this. You can make a new table if you want, x and d of x, or you can just kind of look at it kind of conceptually. But if I take all these values and I subtract 2, it's going to be negative 4, negative 3, negative 2, negative 1. And then my outputs, I'm going down 3. So 2, negative 1, negative 4, and 0. Okay, and so that's what I'm looking for. I think answer is C. Answer's C. If you had an a value, you would multiply the y values first and then take the k value. If you had a b value, you'd multiply that times your x values first and then add your h, okay? Which I guess we don't have here in this example. So here is the practice problem. Please go ahead and pause. Try this one, see what you get. Okay, hopefully you got these parameters, h equals 4, k equals 2, and based upon these values, my h value of 4, this is going to go right 4. So I know that this value, I'm going to add 4 to it, so that's going to be positive 2. So I'm going to throw out c and d, and then my k value, I am going up 2. So essentially I'm adding 2 to this, so I'm looking for a 7. I'm not going down. So answer here is A. All right, hopefully in this video you learned about transformations of functions. You learned about the dilations vertically, horizontally, the horizontal and vertical translations up, down, left, right, and how that can affect x values, right? Multiply times b, add h, and the y values. Multiply times a, add k. All right, next video we'll also focus on transformations and look at some other types of questions that pop up on the AP Precalculus exam. If you have any, if you learned something, is what I want to say, give a thumbs up. I'll see you in the next video.